Hello, so today we're going to take a look at U substitution, and we are going to solve integrals using a substitution method. U substitution, you can say, is a way to undo the chain rule. So we are going to have to find out what is our stuff per se, and we are going to call it U here, the steps, the actual steps to solving U substitution. I'm going to show you a couple of visual tricks to help you realize, or not realize, but help you find out exactly a couple ways to solve this. So we have to find our U. We're also going to have to find our du. And then in steps 3 to 6, I'm going to show you a couple ways that you can solve these. Okay. So if you take a look, if you recall from derivative or unit 3, we know that with a chain rule, there's always some kind of function that's in parentheses or in a square root or even a trig function that we always set as our stuff. The same idea is going to be here. And so what we're going to do is, in this problem, I notice I have the integral of the square root of 4x minus 9. Okay. So what we're going to do is anything that is inside of radicand, we're going to set it as our u. So in this case, my u is 4x minus 9. I don't care about the square root at this point. I just want to know what's inside the square root. And then I'm going to take the derivative of that, and I get du is equal to 4. And since this was the derivative of an x, I'm going to say dx right here. Okay. And so now what I'm going to do is I'm going to plug in that u back into that integral. So what I see is, instead of the integral of 4x minus 9, I'm going to write this as the integral of square root of u du. But the one thing you have to see is that I actually pulled out this constant of 4. So if I pulled out a constant, what I'm going to do is I'm going to stick the reciprocal in front of my integral. Okay? And so when I do this, what you notice is I can actually solve this now that I just have one variable inside the radicand. And just like usual, we're going to rewrite this. So I get u to the 1/2 du. Now that I have this, I'm allowed to use the power rule. So here's my constant of 1/4. I have u, 1/2 plus 1 is 3 over 2, which means I need to multiply by 2 over 3. And then I stick out my plus c. And let's just move this down so later on it helps us out. Okay, and so if I extend this just so I have a little more room, I'm going to simplify my powers, and I get this cancels to 1 and this cancels to a 2. That gives me 1 over 6. Then I get u to the 3/2 plus c. Well, now that I've taken the integral, I can re-plug in my u into this equation. So I get 1 over 6 parentheses 4x minus 9 to the 3/2 plus c. And you're done here. What we also see is that I can rewrite this, so I have that radicand again. And what I get is 1 over 6 square root of 4x minus 9 to the 3rd power plus c. And we're done. So that's the idea. What I'm going to do is give you a couple visual things that we can plug in so we can make sure we take account all our terms. Let's take a look at the next problem right here. And so once again, you notice I do have a set of parentheses, and I also have trig. So in this problem, what we'll do is let's set what's in our parentheses, and if you notice, they're the same exact thing. We're going to set these to our u, so I get u is equal to 7 x squared. I'm going to take the derivative of that, which gives me 14x, and since I took the derivative of an x, I'm going to stick a dx right here. And so here's the visual I'd like to do. Everything that is u, I'm going to underline. So I know I can stick a u here and I can stick a u here. And then I'm going to double underline anything in the du that shows up in our function. So I have an x and a dx. So I double underline that. And if I take a look at my u and my du, the only thing that's not underlined is this 14. So just like before, when I have a constant, I need to pull it out as its reciprocal. And now I can plug in. I've covered the x, I've covered the dx, and I've covered these 7x squareds. So everything I hadn't underlined, which in this case is our trig functions, these will have to remain in our problem. So if I plug these in, I get a secant of u and a tangent of u du. Well, the nice thing is I actually have this integral. So when I integrate this, I get 1 over 14 secant of u plus c. Our last step is to plug in our u, which gives us 1 over 14 secant of 7x squared, and I'm going to make sure I put that in parentheses, plus c. And now you're done. So I found a u, I found the du, and I substituted everything back in to take a basic integral, or in this case a trig integral. All right, let's take a look at the next one. And in here you notice I have two functions. Just like in the chain rule, I want to make sure I pick what is in parentheses. And in this case, my u is going to be this x cubed minus 3x plus 1, since that's what is in parentheses. I then take my du, and I get 3x squared minus 3 dx, right? And then I start doing my underlining. So I notice I have a u right here, and I can stick that in here. And right now, I don't have anything that matches this numerator. But if I play around with my du, I know I can factor out a 3, which gives me an x squared minus 1 dx. And if I underline again, I notice I have a dx, right, which we typically will have right here. So I can underline that part. And I also have an x squared minus 1, which is right here. So the one thing I need to pull out is this 1/3, is this 3 as a 1/3. So I get 1/3 the integral. And if I take a look, I've covered this and this as well as the u. So what I'm going to do is I can stick my du on the top, and on the bottom, since this was my u, I can say u to the 6th. And now I get to use the power rule. The one thing I need to do though is move my 6 to the top to give me a negative 6 power. And now I'm officially able to use the power rule. Let's see, I keep the 1/3. U, negative 6 plus 1 is negative 5. Then I need to multiply by the reciprocal. And if I simplify, I'm going to get negative 1 over 15. And I see this is a negative 5, so I know my u should go in the bottom right here, plus c. And now what I can do is plug in my u. What I get is negative 1 over 15 times x cubed minus 3x plus 1 to the 5th plus c. And there's my integral with my u substitution. Great. Let's take a look at a couple more problems. Okay, so I have another trig integral right here, and if you notice, unlike our previous trig integral where I had parentheses, in this case, all I have is an x. So what we need to do is we're going to take a look at the information that we have, then we're going to think, okay, well, is one of these trig functions an integral or a derivative of another one? And so if you take a look at this, we actually notice that if I were to set my u to be cotangent of x, when I take the derivative, I know that the derivative of cotangent is actually negative cosecant squared of x dx. Right, so if I start my underlying process, I know I have cotangent right here. I also have the dx right there. But I also get this cosecant squared covered from here. The only thing I need to pull out is this negative. So what I do is I hit a negative right here, I integrate. This was covered by du, so was this. This was covered by u. The only thing I need to keep is that power of 5. So I actually get u to the 5 du. And now I can use the power rule, which gives me u to the 6 over 6 plus c. And last thing is to plug in my cotangent again. So I get negative cotangent to the 6th of x over 6 plus c. And there goes my integral. Perfect. We have a couple more to go. Right here it says evaluate the indefinite integral. And what we notice is I have two sets in parentheses. Now I'm going to pick the one that has a smaller power because that the one that has the power attached to it, because we know with the chain rule we're dealing with powers. So in this case, our u should be u is equal to 2 plus 1 over x squared. What I'm going to do is I'm going to rewrite this because right now I can't take that derivative. So I get 2 plus x to the negative 2. Now if I want to, I can take my derivative. I get 2x to the negative 3 dx. And if I want to rewrite this to just make sure I have everything right, this is the same as 1 over x cubed dx. And if you notice, now I can cover my u in here. I can also cover this 1 over x cubed dx right here. The only thing I need to do is pull out this negative 2. So I'm going to pull it out as a reciprocal. I'm going to integrate. In this case, I can put u to the 4th. And we know this whole thing right here is covered by du. And once again, I'm at the power rule. So I get negative 1 over 2, u to the 5th, times 1 over 5 plus c. And once again, the last step is always to simplify and plug in my u. So just to give myself more room, we get negative 1 over 10, because I multiply these two denominators, and my u is 2 plus 1 over x squared. And according to this, it's to the 5th power plus c. And then we're done. Okay. And our final problem, if you take a look, I have trigonometry again, but I also have a square root. So last time we had a square root, what we did was we set what was inside the square root as my u. So I'm going to have sine of t as my u. The derivative of sine is cosine of t dt. If we start our underline process, here's my u, here's my du right here. So we don't even have to pull anything out. All we have to do is put our dt on top. I'm sorry, our du on top. And then inside I get the square root of u. Just like before, I rewrite this to u to the 1/2. And since this is my denominator, I need to move it up to the top. And now I'm allowed to use the power rule. So I get u to the 1/2 times its reciprocal, which is 2, plus c. And that gives us 2 radical. My u is sine of t, so I stick sine of t in here, plus c. And now you're finished. So what I would like you guys to do on your own, I'd like you to try some of this u substitution. So if you take a look at your purple sheet or your blueberry sheet, what I'd like you to do is if you can try numbers 1 through 4 on your packet, and then we can go over them in class the next day. Good luck, ladies. Thank you.